All right. So then if we have a formula, looking at you being able to use this common ions list, we have more complex polyatomic ions now. That's what we're looking at. Yesterday we talked about the simple binary compounds. We're moving to the more complex ones now. Suppose I have something like this. NaClO3. Write this down, please, in your notes. Let's practice. Okay? All right. This doesn't have just two elements. That's real important. I told you this in the very beginning of the class, somewhere along in the first unit or two, and that you need to make sure you're very careful about capital and lowercase letters here. Okay? You don't want to get them confused. This is a capital N, little a. That's all one element. Capital C, little l, all one element. Capital O, one element. If you don't keep your sizes and the clarity between capital and small letters, you're not going to be able to tell what's going on. All right, so neatness really does count. It will help your grade when you're writing symbols and formulas. All right, so this has more than two elements. If it has more than two elements, you need to find some part of this formula on the common ions list. If it has more than two elements, probably ought to write this down, you think? If it has more than two elements, if a formula has more than two elements, in order to name it, you've got to find some part of it on the polyatomic ions list. When you have a compound that has more than two elements, the strong possibility is you've got a polyatomic ion in there somewhere, and you just have to go through that common ions list, that polyatomic ions list, and find the polyatomic ion in order to name that compound. Okay? So you're going to take that symbol right there and this common ions or polyatomic ion list and see if you can find something that looks like some part of the formula. Something that looks like some part of the formula. So do that now. Don't sit around and twiddle your thumbs. Okay? You found one?
Yeah.
Really?
Is it like CIO? That part of it?
No, CLO?
CIO, yeah.
It's a small L. Our eyes would be a little bit different. But yes, that's CLO, chlorate. It's right here. Okay? There it is. All right, so let's start picking this apart so we can name it. We know that chlorate then is CLO with a negative charge, right? So we're going to break it apart. CLO3 with a negative charge. That's chlorate. That's the name of it. Chlorate. Okay? So now we've got to find what the other part that remains is named. What is that going to be named? Sodium. Well, that's one of the periodic table elements. That should be easy, but if you don't recognize it as quickly as Rachel did, then you use your periodic table and find it. Okay? That's what I gave you the periodic table for. It's a tool, right? So there's sodium right there. It's Na. We're going to put it down, the name, sodium. I need to know if sodium has more than one oxidation number. Where do I look for that? What tool do you use to find oxidation numbers? Huh? Periodic table with the oxidation numbers. So sodium only has one oxidation number, a +1, which we only write as a plus sign next to the symbol. Okay? All right. And I know that if I put a 1 plus and a 1 negative together, I get a 0, don't I? So I know the charges are working out here for this to be a neutral compound. Okay? But now I have to name it. Well, naming this is easy. If sodium only has one oxidation number, we don't have to put a Roman numeral on there, and we don't have to do anything to the name of the polyatomic ion. We name it the way it appears on the common ions list. If it says it's chlorate on the polyatomic ion list or the common ion list, that's what we're going to call it here. So the name of this compound is sodium chlorate. Okay?
I thought you did chloride, like from what we just said.
Chloride only applies if it's a binary or if the anion has just one element. Okay? The cation is the positive part, the anion is the negative part. Okay? See, up here in NaCl, the chlorine is just a single element that has gained an electron. That is a chloride. All of these have chlorides in them because they're single elements that have gained an electron. But when you combine the elements together now, what I told you this week was that polyatomic ions are covalently bonded groups of atoms that have an uneven number of protons and electrons. So that particle, that covalently bonded particle, has a charge. In a sense, this polyatomic ion is like a molecule. Only the difference being a molecule doesn't have a charge, a polyatomic ion does. But they're both covalently bonded together. Okay? You with me so far? All right. So naming the polyatomic ions, or the compounds that contain polyatomic ions, is only as hard as finding it on this chart. Okay? That's really all there is to it. Now, that is kind of hard sometimes. But here's the thing. You just recognize more than two elements. Got to find something like it on the polyatomic ion list, and then I can name it the way it appears. Okay? Let's try another one then, okay? Let's see if we can name this compound then, using that same system. Yep, K2SO4. Sulfate? What you said? Okay. So I'm searching through and searching through and searching through this polyatomic ion or common ions list, and I find that this SO4 looks like this SO4 here. Okay? Now let's write that down. SO4. Okay, remember don't take any shortcuts here. Okay, you want to do all the things I'm doing to help figure these things out. The name of this thing is sulfate. Let's just double check things. Okay, let's name the first part of this. That's potassium. So K is potassium. What kind of charge does potassium have? Don't assume. Look it up. 1 plus. Okay? 1 plus. All right? But how many of those potassiums do I have? 2 of them. Okay? All right, so if I have, this is how we did put together the formula for the compound. Down here I'm going to show how to figure out the charges. So I've got 2 1 plus charged particles. And I'm going to add that to a particle that's just 2 negative. So what does that work out to be? 0. So that tells me that this is properly balanced. This must be potassium sulfate. All right? The name of the compound then is potassium sulfate. Got that?
Why do you gotta have 0 at the end, 0 cross through?
Well, I do that just to make sure you're clear it's not an O. Okay, remember that we don't want to confuse things. We can help it. All right. Sometimes it gets confused, but that really is the, I think it's the Greek letter omega. Okay, which is just stands for a 0 in this case. All right. All right. Now then, remember yesterday we said that if we have an atom that has more than one oxidation number on the periodic table of oxidation numbers, then we've got to figure out the charge that goes on it and name it with a Roman numeral to represent that charge. Okay? So this iron, there are not 3 ions here. There's a 3 plus charge on the iron. Okay? So let's try doing this one then. Name this compound. Okay, you're going to try to name this, Tevin. Okay. Alright, so I kind of helped you out here a little bit by giving you the same polyatomic ion that we used a moment ago. That's still sulfate there, SO4. SO4, just like we did in the previous problem, has a 2 negative charge. Okay? And we have iron here as well. We're going to put those together to make this formula here, FeSO4. Okay? Now, what we don't know right now is the charge on the iron. Okay? We know that when I have one iron and one sulfate, I need to have a charge that equals 0. Okay? So I've got one of something here, plus this particle has a 2 negative charge. I've got to have it equal 0. So what's got to go here to make this work out? 2 plus. Well, if I have a 2 plus here, this must be 2 plus. Now I need to look on my periodic table with oxidation numbers and make sure that iron has a 2 plus charge that I can use. And here's iron right here. And sure enough, it has a 3 plus and a 2 plus charge. So I can use the 2 plus charge. Alright? Since this iron has more than one oxidation number, I've got to name it with the oxidation number, and that number becomes a Roman numeral. So this iron is what kind of iron? Iron, Roman numeral 2. Because iron has more than one oxidation number, I have to name the iron with the oxidation number. Okay? And then we just put sulfate on the end because that's the name of the polyatomic ion. Iron 2 sulfate. Alright, does that make sense?